everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज की जो क्लास है वो कंप्यूटर नेटवर्क की क्लास है, जो कि क्लास नंबर आपका 3 है। ऑलरेडी हमने 1 और 2 क्लासेस कर लिया है, जिसमें हमने यूनिट 1 इंट्रोडक्शन कॉन्सेप्ट कर रहे थे। एंड इंट्रोडक्शन कॉन्सेप्ट की अगर हम बात करते हैं तो होपफुली आज के क्लास में हम यूनिट 3 कंप्लीट कर लेंगे। And first of all, it's a huge request from my side to please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And in the last topic that what we had covered up about the microwave transmission, and that we had discussed about it, and many more thing that that what we had discussed about it, and we had done a numerical as well, unshielded, unguided and shielded UTP that we had done in the last classes. So now we'll go ahead with a sort of a numerical, starting with a numerical here. So here we'll go ahead with a numerical. That what we have is your a rectangular wave guide, that is A equals to 2 centimeter, B equals to 1 centimeter. It is filled with deionized water, that is mu equals to 1 equals to 81, then operates at 3 gigahertz. Determine all propagating modes and corresponding cutoff frequency. This has been asked of 5 marks here, and now we'll go ahead with the solutions that what we have to discuss about it, and that what we have to do it. And here in the reference towards it, the solution is, so here this is the solution that what we have is your cutoff frequency should as given, like cutoff frequency given as, that is your FC equals to V naught upon 2 n square upon A plus n square upon B whole under root. So while solving this, we'll get 3 into 10 to the power 8 upon 2 under root 81, then whole under root. We have m upon 0.02 whole square plus n upon 0.01 whole square. And after that, what we have to do is, that is your FC equals to 1.667 under root 0.25 meter square plus n square as well. This is in the gigahertz. The propagating modes ND, the cutoff frequency would be, and that we will be making a sort of a table here that is in reference towards it. We'll discuss about mode and that cut of frequency. For the mode we have is your TE1 E10, then here that we have is your TE01 and TE20, then TE11 and TM11, then TE21, that is 21, and TM21, and of course the TE30 as well. So that what we will be discussing here, and in the reference towards it, that is your the cutoff frequency, and that the cutoff frequency we have is for the TE10 here, that is your 0.833, and for the TE0 and TE20, that is your 1.6 667, and for the TE11 and TM11 that is your 1.863. For the another one 2.357, and then of course for the TE10 30 that is 2.500. That what we have. Now we'll discuss moreover about the switching methods. So here we'll discuss about switching methods, and the switching method that is has been asked in the many time in the examination paper as well. So in the switching method here, they can ask you state with reason if the circuit switching is better suited for the real-time traffic. This has been asked in of 5 marks, where you can answer that in the circuit switching that the channel bandwidth is reserved for an information flow, and to ensure timely delivery of the data, the capacity of the circuit has to be at least equals to the peak transmission rate of the flow, and the circuit is said to be peak allotted, and then the network offers a connection oriented service with the perfect quality of the services, that is your QoS, we can say that, and that is of the terms and the delay, that delay, jitter and bandwidth guarantees as well. And that contentions only occurs when the allocating channels to the circuit during the circuit call establishment. If there are not enough channels for the request, the call established may be delayed and blocked or even dropped. In contrast, once the call is accepted, resources are not shared with the other flow, eliminating any uncertainty and thus removing the need of the buffering, processing and scheduling in the data path. With regard of it, when the circuits are peak allocated, the only measures of the quality of services in circuit switching is the blocking probability of a call. And you can see that following are the some of the reason, like the higher efficiency, fixed bandwidth and a dynamic routing as well. The another thing they can ask you in reference towards the switch method here, that is the switching method. In the reference towards it, they can ask you about it, like define a switch and list the 3 conventional switches method, or explain the various types of switching method with a suitable example. So as I told you about the switch methods here, but the switch like in the form of the, if I'm talking about switched networks, so a switch network is made up of a series of interconnected nodes that called switches, and a switches divides a network into the several isolated channels, and packets sending from the one channel will not go to the another if not specified, and each channel has its own capacity and need not to be shared with other channels as well. And the 3 conventional switches methods are packet switching, circuit switching and method switching, that message switching, that what we have to discuss here. So first I will be writing it out, the switch types of switches here, and that is your first is your packet switching. The second one we have your circuit switching. And the third and the last we have is your message switching. Now we'll discuss each and every part in a deep and in a detail here. That is, the first is the packet switching. In the terms of the packet switching, if I'm talking about, the packet switching is often used in the computer network where the individual user has have a need of the channel intermediately, and while using the channel of the application that requires a high bandwidth, but most of the time each user does not require the channel at all, and such application characterized by the high peak to average requirement for the capacity and are called busty and are ideal for the packet switching as well. In the packet switching, that message are broken into the short blocks and interleaved with other message. Thus the user queue for the channel and share it with one another efficiently, and with regard of it, that data is sent in individual packets, and each packet is forwarded from switch to switch and eventually reaching its destination. Each switching node has its a small amount of buffer space to temporarily hold packets, and if the outgoing line is busy, the packets stay in the queue until the line becomes available. in the reference towards it that the packet switching handles the bursty traffic well as well. Okay, so in the regard of it, now we'll go ahead with the another one, that is your circuit switching here. In the terms of the circuit switching, that the circuit switching is most preferred in the telephone network. Telephone networks are connection before the actual transfer of the information that can take place. An end-to-end path set up beginning of the sessions dedicated to the application and then released at the end of the session, and this is called circuit switching, where the circuit switching is effective for the application, switching is effective for the application, and which makes comparatively steady use of a channel as well. Talking about the next one, this is the message switching here. In the message switching, that is used to describe the telegraph network, and when this form of switching is used, no physical copper path is established in advance between the sender and the receiver. And when the sender and has a block of data to be sent, it is stored in the first switching office, that is the router, and then forwarded later, one hop at a time, and each block is received, it is entirely inspected for the error and then transmitted. A network using this technique is called a store and a forward network. The message was punched on a paper tape offline and sending office, and then read in the transmitted over the communication line to the next office along with the way where is it was punched out on on paper tape as well. And an operator tore the tape off and read it on one of the way many tape readers, one part outgoing trunk as well. And even though such a switching office was called as a torn tape office as well. In the regard of it here, now we will be discussing moreover related to that, as that is that with the message switching, there is no limit on a block size which measures that the routers, the router must have a disk to buffer, and in long blocks it also means that the single block may tie up the routers and router line for the minutes, rendering the messages switching users of the interactive traffic as well. In the regard of it, the message switching does not involve a call setup. It can achieve a high utilization of the transmission line. Message switching is not suitable for the interactive application as well. Now we will discuss and we'll compare, compare the circuit switching and the packet switching here. Compare circuit switching and packet switching. So this is very important that you have to be cleared about it, and this has been asked of 5 marks. So I will be discussing more than 5 points with reference towards some compared circuit switching and packet switching. So the first comparison is that in the circuit switching, that there is a physical connection between the transmitter and receiver, and for the packet switching, no physical path is established between the transmitter and receiver. This is the first comparison. The second comparison we have here in the circuit switching, that all the packet uses the same path, and in this here, that is the packet travels independently. The third comparison in the circuit switching is need an end-to-end a path before the data transmission, and for the packet switching here, that is we have here that no need of the end-to-end path before the data transmission. The fourth comparison of circuit switching we have is that reverses the entire bandwidth in advance, and for the packet here, that does not resolve the bandwidth in advance. The fifth difference we have for the circuit switching is that waste of bandwidth is possible, and for the packet switching, no waste of bandwidth here. And for the sixth difference we have is that recording of the packet can never happen with the circuit switching, and for the packet switching here, that is recording of packet is possible. The seventh difference for the circuit switching we have is that not suitable for handling interactive traffic, and for the packet switching here, that is suitable for handling interactive traffic as well. The eighth difference we have is that is in the circuit switching, that it cannot support store and forward transmission, and for the packet switching here it supports stored and forward transmission here. Now we'll talk about in the detail here, that is explain the user access in ISDN. The user access in ISDN, has been asked in the 5 marks question paper here, and that is the user access in ISDN. Okay, so user access in the ISDN here, the first we have is your, that is the network terminating device, that is NTI. Network terminating device. Okay, so this is known as NTI as well. The NTI provides a physical and electrical termination, okay, of the twisted pair wiring coming from the phone company's that central office. And NTI can support the multiple terminals adapter, and if the equipment supports the S class T interface, then it is necessary to convert between the interfaces and EU interface as well. The second we have is your, that is your physical connection to ISDN. Physical connection to ISDN. In the physical connection to ISDN here, that the terminal's equipment consists of the device that uses ISDN to transfer information such as telephone, a computer, a fax machine, or a video conferencing machine. The S interface is a 8-wire interface, of which 4 wires are mandatory, and it is connected to the terminal's equipment to the customer switching devices, and such as like PBACs or for distance up to about 2000 feet here. Now we will talk about the third one, that what we have is your that is your S/T interfaces. In this, the S/T interfaces that defines the physical network inside your home or office, and in the regard of it here, like S&T interface. The S&T interfaces define the physical network inside your home or offices, and wiring connectors and power are included in the interfaces. And the S&T slash T interfaces utilize the S wire interface, that is your RJ45, and with a 4 wire of signing, 4 wires for power. Now we'll talk about the fourth one, that what we have is your, the last one, that is your U interface. So in the U interface here, the U interface has a single bar of wires with RJ11 connectors that connect to the network U interfaces, and that can drive a signal 18,000 feet here. In that same case, we'll talk about that whatever the salient features of ISDN, and discuss the functions of different layers in the ISDN that we'll discussed here. With the regard of it, you can say that we have to discuss about the silent features of ISDN. And in the case of the silent features of ISDN here, there we have of 6 silent features, and that has been asked. The silent features as well as the function of different layers in of ISDN, that has been asked of the 10 marks. So you have to answer along here. And the first silent feature of ISDN we have is that the main feature of the ISDN concept is the support of the wide range or a voice or non-voice and a non-voice application in the same network. The second we have is your ISDN is digital, and both voice and data are sent as digital packet. The third we have is it is an infrastructure to the support a wide variety of the services and is a network of design for any specific services here. And the fourth silent feature of ISDN we have is the end-to-end digital connectivity implies that the process as the use premises. And the fifth we have is that the voice and the data transmission is integrated over the one system. And the sixth silent feature of ISDN we have the use of existing network for ISDN, we have a silent feature of ISDN here. Now I'll talk about the functions of different layer in ISDN. So the functions are performed by the physical layer are: the first is that encoding and decoding of the signals, the second is the transmission of data, the third is the multiplexing from basics or primary rate, and the fourth is that activations and deactivations of the physical circuits as well. The functions performed by the data link layer are: the first is to establishing and clearing data links, the second is error flow and congestions control, the third is the synchronization. The functions performed by a network layer are that the network layer provides a procedure to make the end-to-end connectivity, that the connections on the network. The first is that addressing and routing, and the second is to establish and clearing network level connections. The third is that the users to the user signing and signaling, and the network level multiplexing and internet working and multiplexing. These were the five here. So what we had discussed, the silent feature of ISDN and the functions and the different layer of ISDN, that what we had discussed about it. Now they can ask you about related what is ISDN and draw the ISDN communication architecture. So in the case of the ISDN, the full form of ISDN, I will just mention it that, because if you don't know, so that is a problem. And that is your ISDN is integrated services digital network. Okay, so this is the full form of ISDN, that is integrated services digital network, and is a set of communication standard for simultaneous digital transmission of voice, video, data and the other network services over the traditional circuits of the public switch telephone network. Now we'll discuss the sort of a question, numerical, that they can ask you is that, and even though they had asked you about this question of 5 marks, how long does it takes to transmit an 8-inch by 10-inch image by facsimile over an ISDN B channel? The facsimile digitizes the image into 300 pixels per inch and assign 4 bits per pixel. Okay, so this is a short numerical here, and that has been asked of 5 marks as well. So we'll do that, and we'll do a solution for that as well. Data rates for B channel is 64 kbps. Number of pixel on image equals to 8 into 10 into 300, that is equals to 24,000 pixels. Number of bits equals to 24,000 multiply 4, that is your 96,000 bits. which is equals to 96k bits. The time required to transmit image, that is we have t equals to 64 kbps upon 96 kbps, that k-bits, that is when we cancel it out we'll go ahead with 1.5 second. So the time equals to 1.5 second, and that will be the answer as well. You have to find it out. Now we'll move ahead with the transmission impairments. With the regard of the transmission impairments here, the difference between the bit rate on a that is a baud rate and a modem constellation diagram has a data point at a coordinates like we have 1 comma 1 and that 1 comma minus 1. For that we have to do it, and just I'll write it down with that a modem constellation diagram. You have to draw that has data point at coordinates 1 comma 1, 1 comma minus 1, minus 1 comma 1, and minus 1 comma minus 1. And how many BPS that can be modem with a parameter that achieved at 1200 baud here, that has been represented. And in the regard of it, what we have to answer is with 1200 baud here. And state 2 persons for using the layered protocol, that what we have to mention as well. So in the regard of it, if I'm talking about so first we'll discuss the difference between the bit rate and a baud rate, and then we'll discuss this particular question here and the diagram here. Then we'll discuss the state 2 person for the using the layered protocol as well. So first, the difference between the bit rate and a baud rate is the bit rate measures the number of data bits, that is zeros or 1, transmitted in 1 second in a communication channel, but the baud rate refers to the number of signals or a symbols changes that occurs per second. A symbol is one of the several voltage, frequency, or phase changes. The next is the baud rate is always less than or equals to the bit rate but never greater. And the modern constellation diagram has a 4 data points and it has a 4 combination. Each baud can transmit 2 bit, and QPSK encodes 2 bits per second. Now we'll draw a diagram for this particular here, and that is we have a baud rate and a bit rate as well. And then we have here it is a bound, that is your baud rate equals to n, and a bit rate equals to n as well. Okay, so this is a sort of, and in here that is we'll be considering about for the bits here, that is your 0 0 1 0 1 0 0, then 1 0 1 and 0 1, then 0 1 0. So this is a bit rate. And now will be the die bit if I'm talking about. So here that is your baud rate equals to n, as well as the bit rate equals to 2n, and for that we have here the die bit, that is 0 0 1 0 1 0, then again 0 0, and then of course 1 0, then again 1 0, again 1 1, and then of course 1 0. So this is the sort of a bit rate where the given data baud equals to 1200, and the bit per second, bits per symbol equals to 2, and the rate equals to baud multiply bits per symbol, and which is equals to here that we will be multiply, that is 1200 multiply 2. 12 2s are 24, so 2400 bps. This is your rate. Okay, so now with this now we'll do ahead the reason for the using the layered protocol we had done before, and now we will be doing the another that is the another question that what we have to do it. And in the terms of it, the question we have here, we have another question, and that what we have is to calculate the required bandwidth if it is in a communication channel that the signal of 10 watt, and the information transmission rate is 10 kbps. So this has been asked in the 5 marks question paper. So we'll write it down. Calculate the required bandwidth if in a communication channel the signal power is 10 watt and information transmission rate is 10 kbps. This has been asked in the 5 marks question paper here. Now we'll be answering this, and that is the relationship between the transmission rate and the communication channel, where the R max equals to 2V, that is bits per second, and the bandwidth R max by 2. The given data for the R max equals to 10 kbps. The bandwidth equals to R max by 2, which is equals to 10 kbps by 2, and that is where we have as your 10 into 10 to the power 3 divided by 2, and for that bandwidth equals to 5 into 10 to the power 3 bps here. Okay, now we'll do another program, another question here, that the numerical that has been asked of 5 marks, and that the question we have here is, that is, if it is required to transmit a data at a rate of a 64 kbps over a 3 kilohertz telephone channel, what is the minimum SNR required for the accomplish this? So let's go ahead and do that. It is required to transmit a data at a rate of 64 kbps over a 3 kilohertz telephone is your 3 kilohertz telephone channel what is the what is the minimized, minimum SNR required to accomplish this. This has been also asked a 5 marks question. So now we'll do a solution here. That is, in the same case, the given data, that the data rate is R equals to 64 kbps, and the channel capacity equals to 3 kilohertz, and that is your SNR. You have to find it out, and for that the C equals to here, that is your W into log 2 1 plus SNR. This is the formula, and you have to put the value, that is your 64 into 10 to the power 3 equals to 3 into 10 to the power 3 multiply log 2 1 plus SNR, then log 2 1 plus SNR equals to 64 into 10 to the power 3 upon 3 multiply 10 to the power 3, then log 2 1 plus SNR equals to 21.33 into 10 to the power 3, and then SNR equals to 2.64 into 10 to the power 6. Then we have SNR min in dB equals to 10 log 10, that is base 10 SNR. Now for that we will have to do that. After this we have is your 10 log 10, that is your 264 into 10 to the power 6, and then of course we have 64.2 dB. So this will be the right answer, and how you will have to find it out. Now we'll discuss moreover about the explain degradations of the signal quality due to the attenuations and the delayed distortions. With the regard of it, we will be discussing about the degradations of the signal quality due to the attenuations and the delayed distortions. That is, this has been asked in 5 marks question paper. As a signal propagates along a transmission line, its amplitude decreases, and this is known as a signal attenuation, and it is a loss of in signal power as it is transferred across the system. Signal attenuation increases as function of frequency, and in the general of the signal get distorted because different frequency components undergo different attenuation and different delays as well. The problem of attenuation, what we will phase it out is the first is that the received signal strength is reduced and the receiver circulatory may not be able to detect the signal. The second is that the received signal strength must be sufficiently higher than the noise. The third we have is that the attenuation is an increasing functions of frequency. With regard of it, the first and the second considerations are dealt with by an attenuation to a signal strength and the use of the amplifier or the repeater. But for a point-to-point link, the signal strength of the transmitter must be strong enough to be received intelligibly, and but not so strong as to be overload the circulatory for the transmitter or the receiver, which would cause distortion. Beyond a certain distance, the attenuation becomes unacceptably great, and a repeater or amplifier are used to boost the signal at regular interval. These problems are more complex for the multi-point lines where the distance from the transmitter to receiver is variable. And the third consideration, known as attenuation distortion, is particularly noticeable for analog signals because attenuation is different from the different frequencies, and the signal is made up of a number of that is the components at a different frequency. The received signal is not only that reduced in strength, but it is also distorted. For that case, we can say that to overcome this problem, this technique are available for equalizing the attenuation across a band of frequency, and this is commonly done for the voice grade telephone lines by using the loading coils that changes the electrical properties of the line, and the result is to smooth or out attenuation effect. That the another approach is to use amplifier that amplify high frequency more than the lower frequency as well. The delay distortion is the critical in the digital data, and the delay distortion causes the inner symbol interfaces. Hence, the maximum bit rate for the channel is reduced. The delay distortion is caused by the fact that the velocity of the propagation of signal through a cable is different for the different frequency. For a signal with the given bandwidth, the velocity tends to be the highest near the center frequency of the signal, and to the fall off towards the two edge of the band, and thus the various components of the signals will arrive at the receiver at a different time. This effect is referred to as a delay distortion because the received signal is distorted during the varying delays experienced as it is constituent frequency. And the delay distortion is particularly critical for the digital data that consider that a sequence of the bit is being transmitted using the either analog or a digital signal. Because of the delay distortion, some of the signal components of the one bit position will spill over into the other bit position, causing symbol interferences, and which is major limitations to the maximum bit rate over the transmission channel as well. Now we'll discuss moreover related to the data rate limits and the Shannon capacity. So we'll discuss about it. Data rate limits and Shannon capacity. So this has been asked in of 5 marks. That is what does the Nyquist theorem have to be with the communication. So that what we have to understood the Nyquist theorem, that what we'll discuss as well, and that is the another one, that is your Nyquist theorem. Here, the Nyquist theorem gives the different bit rate formulas that define the theoretical maximum bit rate, and it says that if you have a function whose Fourier spectrum does not contain any signs of cosines above f, and then the sampling of the function of frequency of 2f, and you capture all the information there is, thus the Nyquist theorem is true for all the media. The Nyquist gives the upper bound for the bit rate of the transmission system by calculating the bit rate directly from the number of the bits in the symbols or the signals levels and the bandwidth of the system as well. If I'm talking about the Nyquist theorem here, the Nyquist theorem states that for the noiseless channel, that is, we have a C equals to 2b log 2l, and that is your the another C, where C is your capacity in bps, and B is equals to, that is your bandwidth in hertz. So here, how much minimum bandwidth is required to digitally transmit an analog stream which is generated at 50 kilohertz after Manchester's encoding. So that what we have to do it, and in the reference towards it, that first you have to know about the Manchester encoding. In the reference towards the Manchester encoding, in the Manchester encoding, the duration of the bit is divided into the two halves. The voltage remain at one level, and during the first half, and the moves to the other level in the next second half. The transitions in the middle of the bit provides the synchronization, and the minimum bandwidth of the Manchester is 2 times that of the NRZ, that is your Nyquist theorem here. And for that, the Manchester encoding waveform of 8-bit data stream, that is 11000101. That's like 11000101. So I will represent you like that. So here that is and for that sake we have 1, then we have 1 0 0 0 1 0 1. So this is the representation. This is your binary 1, this is positive V, and this is binary 2, binary 0, that is negative. So this is the representation of Manchester encoding waveform of 8-bit data, that is your 11000101, and if the data is a 1 and the first half of the bit time period is sent to the positive level and the second half of the period is at its negative level, for that data bit of the 0, first a negative signal and then a positive signal here. Now with regard of it, so the minimum bandwidth, if I'm talking about with reference towards it, for the minimum bandwidth, this minimum bandwidth we have BW, that is greater equals to 2 into multiply 50 hertz kilohertz, and that is your bandwidth equals to 100 kilohertz. And for that we will do a sort of a numerical here, and then we'll discuss the short answer questions of 2 marks. And the numerical, the last numerical we have to do here is your a file size 0.008 GB. How long does it takes to download this file using 8 Mbps channel? This is of 5 marks. So the given data we have is your file size equals to, that is 0.008 GB, and the channel capacity we have here is your 8 Mbps. Okay, and for the time of download, time to download equals to file size upon channel capacity, and to time to download, that the file size we have is 0.008 into 10 to the power 9 upon 8 into 10 to the power 6, and for that time to download is equals to 1 second. Okay, now short answer question here, that is of 2 marks, that what we have to discuss here. And the first question they can ask you, which of the communication mode supports two-way traffic but it only in one direction? This has been asked of 2 marks question. So half duplex communication mode supports two-way traffic but only in one direction, so half duplex will be the answer. The second question they can ask you is that the filter used to a telephony and offices limit high frequency components or the telephone lines. What is the cutoff frequency when ADSL modems are used in the customer lines? In the regard of it here, that they can ask you is to consider DSL modems, which is a high speed data communication devices that transmits over the existing telephone network. DSL signals operates in the high frequency ranges above the 3000 hertz limit for the voice conversation, and in order to separate the DSL data signals from to regulate the voice signals, the signal must be sent into the two different filters, a low pass filter and to amplify the voice for the telephone signal, and a high pass filter to amplify the DSL data signals as well. In the regard of it, how many layers are there in the X.25 protocol that enlaces the layers? So here in that same case, there are the 3 layers in X25. The first is the physical layer, frame layer and a packet layer. This has also been asked, and that has been asked in the 15 and 16. So the physical layer deals with the physical interfaces between the that is your attacked station and the link that attacks that station to the packet switching node. The second is your frame layer, that is your that facilitates reliable transfer of data as the physical link by the transmitting the data as a sequence of frames. The third we have is your packet layer here, and the packet layer that is responsible to the end-to-end connections between two DTEs as well. So now we'll discuss what are the applications of computer network. This has been asked of the 2 marks as well. The application of the network computer network we have here is that the first is that the resource sharing, like hardware, computing resources, and disk printers, and the software like application software. The second is the information sharing, that is easy accessibility from anywhere files, databases. Communication is that email and message broadcasting, and the fourth is the remote computing. Now the next question we have is that why star topology is commonly preferred, and in that case it gives the high reliability, more flexibility, and a high bandwidth since there is a central control point. The control of the network is easy to and a priority that can be given to the select nodes as well. The next question, what define computer network? A computer network consists of 2 or more computers that are linked in order to share the resources, exchange data files, and to allow to electronic communication as well. The next we have is what is LAN. A LAN is a common name used to describe a group of devices that shares a geographical location. LAN is limited to a signal building or a campus. Now the fourth is that what is the difference between a packet and a frame. A frame is a PDU, is a data link layer, where is a packet of PDU at a network layer, and a data link header and a footer are added to packet to create a frame, and a frame is therefore a set to be encapsulated a packet. Now we'll talk about the differentiate between the bit rate and a baud rate. Baud rate is the number of pulses per second that are sent to be a given a wire, and a bit rate is the number of bits of data that are transmitted on a given wire per second. Now the next question they can ask you, what is OSI? So a standard that specifies a conceptual model called Open System Interconnections OSI network reference model, which breaks the network communication into the 7 layers. That the layers were application, presentation, session, transport, network, data link, and physical. These were the layers, and that you have to be gone through with that. And if it is asked more than 5 marks or 10 marks, you have to draw the architecture, that what we had discussed in the last classes. Now talking about the next one, that is they can ask you what on which feature a LAN can be differentiated. The first is the topology, protocol, and media for transmission. What are the advantages of LAN? So the advantages we have is that the flexibility, speed, reliability, resource sharing, centralized management, privately owned network. Now what is meant by a protocol? A protocol is a set of rules that governs that data connection. Protocols defines the method of communication, how and when to communicate. The next is what are the different network topologies to organize the computer network, and list out the 4 basic network topologies. So as I discussed about it, that is the mesh topology, star topology, bus topology, and a ring topology. The next question they can ask you is list the differentiate between the circuit switching and a packet switching. As I told you about the circuit switching and a packet switching here. For the circuit switching here, that is circuit switching is the physical connection between the sender and the receiver. Packet switching is no physical connection between the sender and the receiver. The second difference is that all circuit switching, in circuit switching all packets use the same path, and in packet switching all packets uses the different path. The third difference we have circuit switching, a waste of bandwidth is possible, and in a packet switching no waste of bandwidth. The fourth difference and the last difference of circuit switching we have, in circuit switching the congestions occurs for the per minute, and in packet switching that congestions occurs for the per packet. The next question they can ask you is you define throughput. That is the throughput is defined as an average successful traffic transmitted between the stations per unit time. And the next question and the last question of this session is your defined channel capacity. It is the maximum achievable throughput for a particular type of an access scheme is called the capacity of the channel. That's all. First of all, it's a huge request to all of you, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well, and you will get all the related information that what we had provided. You can go through with that. We had completed the web technology, we had completed operating system, we had completed many more subjects in reference towards and even though we are dealing with that is your reasoning as well. I mean, there as well we had completed non-verbal reasoning, and we had we had completed verbal reasoning, and we had started with non-verbal reasoning here, and you can go through with that as well. In the computer network unit 1 we had completed in this class, and this is we had completed the goals and applications of network structures and architecture, the OSI reference model, service network topology design, delay analysis, backbone design, local area network design, physical layer transmission media switching method, ISDN and terminal handling as well. यूनिट 2 में हमें जो करना है नेक्स्ट क्लास से वो है मीडियम एक्सेस सब लेयर, नेम है आपका यूनिट 2 का मीडियम एक्सेस सब लेयर, चैनल एलोकेशंस, लैंड प्रोटोकॉल, अलोहा प्रोटोकॉल, ओवरव्यू ऑफ द IEEE स्टैंडर्ड FDDI, डेटा लिंक लेयर, एलिमेंट्री डेटा लिंक प्रोटोकॉल एंड स्लाइडिंग विंडो प्रोटोकॉल, एरर हैंडलिंग। यूनिट 3 है नेटवर्क लेयर, जो कि हम नेटवर्क लेयर पढ़ेंगे, पॉइंट टू पॉइंट नेटवर्क, राउटिंग, कंजेशन कंट्रोल, इंटरनेटवर्किंग, TCP, IP पैकेट, IP एड्रेस, IPv6. In Unit 4, we have to discuss about so here that is unit 4 we have to cover up, that is your transport layer, and the transport layer, that is we have to cover up the design issue, connections management, sessions layer design issues, remote procedure calls, presentation layer design issues, data compression technique, cryptology, TCP window management as well. And then we have to discuss unit 5, that is your application layer. In that we have to discuss about the application layer, file transfer, access and management, electronic mail, virtual terminals, other application, example network, internet and a public network as well. So class आज के लिए इतना ही. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give your suggestion on the comment box. Please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And you will be you can go through with this playlist. You will be providing each and every video which we had uploaded in reference towards you can go through with the playlist as well. Thank you.